Hey there, you're in 11. It's the middle of the night, and I don't know how many takes I have done the re-recording so that to make things much more interesting, or at least create something timeless for you guys that you can always refer whenever you do some consolidation. So today we're gonna go and dwell into a topic called the hexadecimal. This is a very calculation heavy kind of thing that will needs to use your brain. I don't know how much you have covered, but looking at the mock examination, I felt this is a topic that we should look into before moving into more consolidation and new learning for our computer science topic. So let's start with hexadecimal. So let's start with hexadecimal. So hexadecimal, it's a base 16 number. In binary, it was base 2 numbers. Okay, base 16. Hex means 6, decimal 10. So 10 plus 6 will be base 16. And in binary numbers, you know that we just only have zeros and ones. But in hexadecimal, there will be 16 different numbers. And it will range from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, this will be similar as the base 2. And since this is the base 16 numbers, we need to add in 10 to 15. But in hexadecimal, the number 10 is replaced to A, B, C, D, and F. Using another color to visualize this, A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15, sorry. So how do we convert hexadecimal numbers to a decimal number? Now, you've seen hexadecimal before, where sometimes in colors we can represent something like FF, B7, and A2. Something like this. You've seen that in the CSS colors, for example. Now, let's take a hexadecimal number as an example. But before that, we need to use a table mathematical method that we use since in base 2. And since this is base 16, from the right to the left, we can put in the number 1. And then we have 16, and then 6, because 1 multiplied by 16 will be 16. And then 16 multiplied by 16 will be 256. It will be 4096. This will then form a table for the hexadecimal calculation. So for example, A2, if we want to find out the hexadecimal value of A2 to decimal, we can place A right over here, and since because A represents 10, so 10 can be placed over here. Remember that A represents 10, so 10 can be placed here, and then the 2 number can be placed right over here. So we can multiply base according to the number at the top, so 100. 10 multiplied by 16 would be 100, and this will be 2 multiplied by 1 according to the top, and in total this will be 160, and this will be the 2, and add them up together, the hexadecimal value of H2 to decimal will be 162. Let's do an example. I'll clear out some other distractions so we can do a hexadecimal value, let's say B7. All right, so let's put B right over here and then 7 right there. Remember, B is the number 11, and then 7 is just 7. So 11 multiplied by 16 and 7 multiplied by 1 is because we can use this to multiply at the top of the table, and we could then find out what's the number. 11 multiplied by 16 will be 176, And of course, this is simply just 7. Add them out together. This will be 183. Now, what about converting decimal to hexadecimal? Let's use the table again. 116, 256, and 4096 right over here. And this time, let's say we have the number 196. Now, let's break down the table. 196 is not above 256. And of course, it's definitely not above 4096. So we are not going to look at these tables at all. And 196 can go into the column of 16. So we put 196 right over here. We don't need to put anything in 1 for now because we need to then divide. We need to solve this column first. Use another color. So in order to find out the hexadecimal value, we can use 196 as a decimal. Manually, we're going to divide. So 1 over 16, this will be 36. And then 2 multiplied by 16 will be 32. And then we will then have a remainder, or 4. So once we have the remainder, we can stop. We don't need to add in any kind of points. And right over here, we can then see that 12 represents a number. We'll convert this number to a hexadecimal value, which is C. And then we can place this remainder over here, 4. So the decimal value of 196 converted to hexadecimal will be the value C4. Let's do another one. Let's say we have a number, this time 100. Of course, we don't need to do any of these columns because 100 is not above these numbers. And then 16 right here, we can place the number right here for the time being. And then let's do the division on our own. The number to multiply, 16 will be 16 multiplied by 6 will be 96, and this will be 4, because 6 divided by 96 will be this, and then the decimal value of the. So once we're done, this number will be converted over here, and then this remainder will be placed here, and then this will be the number of 6 and 4 of the hexadecimal value. Now, this method can be quite mathematical, and since we can't bring any calculator into the exams, you need to do this calculation quite manually, and you have to do the division or multiplication with a lot of reference paper or writing things out with your calculator. If you don't prefer to do this mathematical method, there's another method you could use. All right, for method number 2, we can first write down. On the most right, we can start by writing DEC, representing decimal. This will be the column itself. And right next, we can just write down the base 2 number, 1, 2, 4, 8, 16, 32, 64, and 128. This will be the base 2 table that we so commonly use. Now, the next one, we will use something like we call nibbles, not the full base 2 to 128. We could use something like a nibble, such as 1, 2, 4, 8, and then 1, 2, 4, 8. At least we have 2 of these columns right here. And then here we will write down the hexamal, or HEX column. Remember, A for hexadecimal is 10, B is 11, C is 12, D is 13, E is 14, F is 15. Now, let's say if we want to convert the hexadecimal value of C7. Now, Let's write down C7 right over it as the hex column. Remember, C is the value of 12, so let's convert this to a nibble value, which is 12. So at 12 will be 8 plus 4, so in binary it will be 1100, because 8 by 4 is 12, when this is converted right over here. Now, this will now convert over here with the value of 7, which is 0, 1, 1, 1 in binary values. Transfer all of these to the main 8-bit binary, 1100, 0, 1, 1, 1. But then we'll be able to find out what is the decimal value by combining 1 to 8, 64 plus 4 plus 2 plus 1. And in total, it will be, let's try with another hexadecimal value. So let's use maybe B2 right now. Remember, B is 11 value, so convert B right over here will be 11. So we could use 1, 0, 1, 1, because that's 8 plus 2 plus 1 will be 11. And this will convert right over here to this nibble value. It will be 0, 0, 1, 0, because there's only 2 over there. Convert this to here. To find out the decimal value, we just add up 1 to 8 plus 32 plus 16 and then plus 2. Added up together will be 178. What about converting decimal to hexadecimal? Let's say we have a number 86. We can start by on the right because that's decimal number. Simple enough. We can start by just labeling the binaries for 86 because this is definitely lesser. We're going to put 0, 64 because that's within there. 64 plus 32 is definitely over. And 64 plus 16. 64 plus 16 is definitely 80. All right, so we have the 80 value right here. So right now we just need to fill in 4 plus 2. And now we have the binary value of 0101, 0110. Convert this over here. And then we are able to now find the hex value for this binary number. So this added up together is 5, and this will be 6. So the hexadecimal value of 86 decimal will be 5 and 6 for hexadecimal. Let's do another example. This time we have the number of maybe 56. Maybe. Put the number here. Here, definitely is 0. This is also 0 because it's over. So 32, definitely. 32 plus 16 is 48. All right, so 48. And 48 plus 8 is definitely 56. So 1, 0, 0, 0. Right down over to the nibble of 8421. 1, 0, 0, 0. Using the hexadecimal letter, convert this will be 3, and this will be 8. So the number of 56 for hex will be 3 and 8. All right, I hope this video helps you and helps you to distinguish the two methods. And good luck in your calculation and conversion.